In this video, I'm going to show you two methods to solving this integral, which are both important in your calculus exam. So let's start off with the first method. So the first one, we have the integral from 0 to pi over 4 of 1 all over 1 plus tan of x can be written as the sine of x over the cosine of x, right? This is common knowledge. And now we have to multiply top and bottom by the cosine of x. So the integral from 0 to pi over 4 of multiply the top by the cosine of x, we have the cosine of x divided by the bottom by cosine of x is going to be the cosine of x plus the sine of x. Just multiplying top and bottom by the cosine of x. And now next step is to multiply this integral by 2 and nullify the effect by multiplying the integral by 1/2. And now I is going to be equal to 1/2 the integral from 0 to pi over 4 of this 2 cosine of x. I'm going to write it as the cosine of x, and then I'm going to bring the next cosine of x here, right? All this one divided by the cosine of x plus the sine of x, and then dx, right? So what I'm going to do to the numerator, I'm going to add the sine of x here. And then to nullify this sine of x, I have to subtract the sine of x. And now I can group this integral into two different integrals. The first two terms into one term, and the next two terms into another one. So we have I to be equal to 1/2 the integral from 0 to pi over 4 of the cosine of x plus the sine of x. All this one divided by the cosine of x plus the sine of x dx plus 1/2 the integral from 0 to pi over 4 of the cosine of x minus the sine of x. All this one divided by, here I'm going to write it as the sine of x plus the cosine of x. That's the same thing. And now you see that the first one, the numerator and denominator are the same. So they'll just cancel out beautifully. And you have 1/2 the integral from 0 to pi over 4 of 1 dx plus 1/2 the integral from 0 to pi over 4 of the cosine of x minus the sine of x divided by the sine of x plus the cosine of x dx. So the second one, we are going to do a u sub, right? So the second one, I'm going to let u to be equal to the denominator, which is the sine of x plus the cosine of x. When I do that, du is going to be equal to, differentiating this is going to be the cosine of x minus the sine of x dx. So in place of this one, I'm going to replace that with du. Right, so let's look at the change in limits. When x is equal to 0, the lower limit, u is going to be equal to sine of 0 plus cosine of 0. Sine of 0 is 0, cosine of 0 is 1. And then when x is pi over 4, so u is going to be equal to what? Sine of pi over 4 is the square root of 2 over 2, and cosine of pi over 4 is the same thing, square root of 2 over 2, which is the square root of 2. Right, so now the integral is now like this. I is going to be equal to 1/2, then integrating this in the x world is x from 0 to pi over 4, right? And now plus 1/2, integrating this is now the integral from 1 to the square root of 2, from 1 to the square root of 2. This one is du from our u sub all over u, right? So I is going to be equal to, plug in the limits here, we have 1/2, this one is going to be pi over 4 minus 0 plus 1/2, the integral of 1 over u is the ln of u, like this. Then you put the limits of integration from 1 to the square root of 2. I here is going to be equal to pi over 8, because 1 times pi over 4, and then plus 1/2, you plug in the limit, you are going to have the ln of the square root of 2 minus the ln of 1. So I here is going to be equal to pi over 8 plus 1/2 times the ln of the square root of 2. ln of 1 is 0. I here is going to be equal to pi over 8 plus this is 1/2 ln of 2 raised to the power 1/2. That is the square root of 2. So this is pi over 8 plus, using the power rule of logarithm, this 1/2 can become and can come and multiply this 1/2 in front here. Then you have the ln of 2, and this is equals to pi over 8 plus 1 over 4 ln of 2. So with the first method we are done, and then I evaluated to this pi over 8 plus 1 over 4 ln of 2. Let's keep this in mind. And now let's tackle the second method, right? So second method, right? So with the second method, we are going to use what we call the King's rule. Right? The King's rule states that the integral from a to b, this is only for definite integrals, the integral from a to b of f of x dx is equals to the integral from a to b of f of a plus b minus x, all this one dx, right? So if we can recall our integral I is going to be equal to the integral from 0 to pi over 4 of 1 all over 1 plus the tangent of x, right? And then dx, correct? So this is f of x. How do you find f of a plus b minus x dx? So here a plus b, in our integral, a plus b minus x is going to be equal to, the lower limit is 0, the upper limit is pi over 4 and then minus x. This is just equal to pi over 4 minus x. So I'm just going to replace pi over 4 minus x in our integral, and that is going to be the same as I, our integral, because this term and this term are equal, right? So this is I, which is equals to the integral from 0 to pi over 4 of 1 all over 1 plus tangent of x can be written as the tangent of a plus b minus x, which is pi over 4 minus x. This is pi over 4 minus x dx. This is the King's rule of definite integrals. Cool. So we know that the tangent of a minus b is the same as the tangent of a minus the tangent of b all over 1 plus the tangent of a times the tangent of b. From trigonometry, right? So when we have this, the tangent of pi over 4, how can we express the tangent of pi over 4 minus x? So tangent of pi over 4 minus x, using this identity, is going to be the tangent of pi over 4 minus the tangent of x all over 1 plus the tangent of pi over 4 times the tangent of x, correct? Right? So this is equals to tangent of pi over 4, that's tan 45. This is 1 minus the tangent of x all over 1 plus tangent of pi over 4 is 1 times tangent of x is the tangent of x, and this is the same as the tangent of pi over 4 minus x. So in place of tangent of pi over 4 minus x, I'm going to replace it with this guy and hope for the best. Let's do that. I is going to be equal to the integral from 0 to pi over 4 of 1 all over 1 plus tangent of pi over 4 minus x can now be replaced with 1 minus the tangent of x divided by 1 plus the tangent of x dx. Right, so I is going to be equal to the integral from 0 to pi over 4 of 1 all over, this can be written as 1 plus the tangent of x plus 1 minus the tangent of x, all this one divided by 1 plus the tangent of x. That is just multiplying in with this. Okay, so tangent of x is going to cancel tangent of x, right? And this is left with the integral from 0 to pi over 4 of 1 all over, this is now 1 plus 1, 2 all over 1 plus the tangent of x, and then dx. And this is the same as we are going to multiply by the reciprocal of this guy, and that is going to be the integral from 0 to pi over 4 of 1 plus the tangent of x all over 2 and then dx. So here I is going to be equal to 1/2 is a constant, it comes in front, and you are integrating from 0 to pi over 4 of 1 plus the tangent of x dx. Okay, so I is going to be equal to 1/2, then integrating 1 in the x world is x plus what is the integral of the tangent of x. Integral of the tangent of x is the natural logarithm of the secant of x, like this. And then you are done with the integration. You put the limits of integration from 0 to pi over 4. So this the integral of the tangent of x is the natural log of the secant of x. Alright, so now let's plug in the limits and see whether we get the answer in the first method compared to the first method. So this is going to be pi over 4, right, plus the ln of the secant of pi over 4, like this, minus, when you plug in 0, what are you going to get? You have 1/2. This is 0 plus the ln of the secant of 0, like this. Cool. You know secant is 1 over cosine, right? So secant of x is equal to 1 over the cosine of x. So that means secant of pi over 4 is the same as 1 all over the cosine of pi over 4. So cosine of pi over 4 is 1 over square root of 2. So secant of pi over 4 is going to be the square root of 2. So secant of pi over 4 is the square root of 2. So I'm just going to replace that in our integral here. So we have 1/2 pi over 4 plus the ln of secant of pi over 4 is the square root of 2, like this, minus 1/2. This is 0 plus the ln of secant of 0 is 1, because 1 over the cosine of 0 is 1. So this is the ln of 1. So I is going to be equal to, multiplying in, we have pi over 8 plus 1/2 the ln of the square root of 2, which can be written as 2 raised to the power 1/2, minus this is 0, ln of 1 is 0, so minus 1/2 times 0 is 0. So I is going to be equal to pi over 8 plus 1 over 4 ln of 2, using the power rule of logarithm. So this is what we have for the second method. So the answer is pi over 8 plus 1 over 4 ln of 2. So when we go to the top, we see that this one is also equal to pi over 8 plus 1 over 4 ln of 2. So we see that both methods will give the same answer. And these are the two different methods that I want to show you. So in case you encounter this in your calculus exam, so you may know which one to use, which will help you achieve the answer within the shortest possible time. So let me know in the comment section which method you really like, and then please give me a thumbs up and support my channel so that I will continue uploading engaging tutorials on integrals. I thank you for watching this video, and I will see you in the next one. Bye bye.